Hey there, have you ever flipped through your playlist one song at a time and wondered how does a music app knows which song to play next? That's because of linked list, the backbone of how many dynamic features are built in a software. Today we'll be talking about linked list by comparing it to something very similar, a book. What happens when you open a book? You read through the first page, you flip and you go to the second page. Well, in a book, each page contains some information and each page naturally leads you to the next page. Because of this binding, you cannot directly go to page 50 before you have gone through all the previous pages. This step-by-step navigation from one page to another is exactly how a linked list stores and accesses its data. For a better understanding, let me explore this analogy further by taking a printed book and a loose leaf binder. First, imagine a printed book with all of its pages stick together in a fixed order. Here, every page number corresponds to a fixed position in this book, just like an index in an array. Now, if I were to go to page 50, I don't have to need to go through pages 1 to 49. I can just directly go through it. This is just like an array where I get fast lookups just because of its index. But if I were to insert a page between, let's say, page 5 and 6, I'd have to tear the whole book apart and resew it. Similar to how arrays behave, insertion and deletion in the middle will will cause me much more time and space because I have to shift all the elements after the required element. Okay, now imagine a loose leaf binder where there are rings in between, which I can open and close. Here also, each page has its own data, and the rings act like links connecting one page to another. To read it, I have to go through each page flip by flip. But if I were to insert a page between page 5 and page 6, I'd have to go to page 5, open the links, insert the page, and close the links. If I were to remove a page, if I were to remove page 5, I just go to page 5, open the links, remove the page, and close the links. Remember, here I only have to modify the neighboring nodes, not all of the nodes, just like arrays. So, what's the difference? When it comes to quick lookup, arrays are a better preference, but when it comes to insertion and deletion, linked lists are a better choice. Alright, now let's zoom in on the building block of linked list, which is node. So exactly what is a node? Well, a node, a node consists of two things, data and a pointer. Data is the value to be stored in a node and pointer is the reference to the next node. Okay, so now that we know what a node is, let's build our own linked list from scratch in our own code editor. The first step is to create the node class, which is going to be the building block of our linked list. Then we define the data variable, which holds the value of our node. Then we define the next variable, which is going to be the pointer, which is going to hold the address of our next node. Then we define the constructor, which is basically a special method that runs every time a new node is created. It takes one argument, data, which is going to be the value the node is going to hold. And one thing to remember here is that we are explicitly setting next to null because once a new node is generated, there is no other nodes to connect it to it. So that's why the next is null for now. So now let's move on to step two, which is creating the linked list class. So first we create a head pointer, which basically points to the first node of a linked list. Then then we create a method which basically appends the new node at the end of a list. To do that, first we create a new node with our desired data. Then we check, is the list empty? We check it by is the head null? Because if head is null means the list is empty. So if head is null, we point head to our new node because now new node is our first node and head's responsibility is to point to the first node. But what if it's not an empty list? So we grab a temporary variable temp, which is pointing to the first node, and we loop temp dot next until it's null because we are we want temp to point to the last node. And To do that, we want temp.next to point to null. Now, once the loop finishes, we know that temp has been pointed to the last node. So, putting temp.next equal to new node hooks the new node to our last node's next pointer. Basically, it just appended the new node to the end of a list. Now, let's create another method which is going to insert a new node at a certain position. So, starting off by creating a new node with our desired data. And for the rest of the code, I'm going to go back to my slides for a bit more visualization. So first things first, we're going to check that is the position that we are trying to insert a new node, the first node. So we check that by if position equal to 0. And if that is the case, then the first statement is state new node dot next equal to head. Head points to the first node. So if new node wants to become the first node, its next pointer should point to the second node, or its next pointer should point to the former first node. So its next pointer is now pointing to the first node. But since now new node has become the first node, head should now point to the first node, which is new node. And now it should return. Okay, let's go to the next case that if it's not the first node. But so now we take a temporary variable which points to the same location as head, and now we loop temp until the position just before the position we want to insert a new node at. Okay. So first we're going to talk about the case when the position is out of bounds. If the position is out of bounds, the temp will go to the first position, then the second and the third. But when it goes to third, the temp becomes null. And as we can see in the for loop, that when temp becomes null, the for loop gets finished. And when it gets finished with temp equal to null, we, we print out position out of bounds and we return. Okay. But what if it's not? So then we put new node dot next is equal to temp dot next. So temp is basically at the third position and position is basically at the fourth position. I forgot to say, but we're taking position to be at the fourth position. So temp is at third position. So new node now points to temp dot next, basically to the positions variable, positions place. Okay. And the next statement states that temp dot next points to new node. What does that do? Basically, we want new node to be at the fourth position. Okay. So if it wants to be at the fourth position, third one should point to fourth one should point to fifth. Currently, we have done fourth one is pointing to fifth. Now we have to do third one point to fourth. So let me just get a better visualization at this. This is the same diagram as this one. And now we want the third one. Currently, the third one is pointing to the fifth one. So now third one is pointing to the fourth one. Okay, so now let's head back to our editor for the rest of the code. As you can see that we have already discussed this code. So now let's get back to the rest of the code. So the next method I'm going to talk about is the print method, which is by the name of it, you can guess that we are going to print the list. So we start off by taking a temporary pointer, which points to the same location as the head does, which is the first node. And then we loop temp until temp becomes null. And while it becomes null, it prints all the data followed by a shift arrow, followed by a right arrow. And then to indicate that the list has ended, we print null at the end. Now, step 3, write the main program to see this in action. Okay, so first let's create a linked list object and then add, now let's add some sample nodes. Then we do the print function to print the list. So the expected output for now should be this. And then we should use, by using the newly created method and printing it, we should get the newly generated list with 50 at the second position. Okay, let's check it. And that's it. You have now generated your whole linked list with insertion, traversal, and insertion at key position. Okay, so before ending this session, let's have a final recap or a summary of what all we have covered. So we have covered what a linked list is, a collection of nodes where each node contains a value and reference to the next node in the list. Why linked lists are better than arrays? Well, they are sometimes better than arrays because they are more flexible in the case of insertion and deletion and can grow or shrink dynamically. And how to create and traverse a linked list in Java? By first creating a node class and then creating a linked list class to chain all the nodes. Okay, so now let's look at some real life examples before moving on to the next segment. So, music playlist is one example where when you click next in a playlist, the app moves to the next song. Inside the app, the songs can be stored in like a linked list data type structure where when you press on next, it goes to the next node or the next song. And now the next example would be browser history in Chrome or Firefox. When you press back, you go to the previous page, and when you press next, you go to the next page. When you press forward, you go to the next page. Here, each node is connected to both their previous and next nodes. Now, this is another data structure. This is another special type of linked list. It's called a doubly linked list, where each node is connected to both their previous node and their next node. The next example would be an image viewer. Now, every user would sequentially go through their photos. So, in photo galleries, next photo and previous photo functionality can be backed by a linked list data type structure. Now, before ending this session, let's have a quick trivia challenge to check how much we have learned. The first question is, if a linked list has 5 nodes, how many next pointers are there? The correct answer is 4. It's because if a list has 5 nodes, that means each node has a next pointer connecting it to the next node. But the last node has a null pointer, which means it's not connected to any other node. So, hence, a linked list with 5 nodes has only 4 next pointers. Okay, so now the next question. What happens if the last node points back to the first node instead of null? Well, the correct answer is the list goes into an infinite loop. It's because when the last node connects back to the first node, there is an infinite loop of going to the next node endlessly. And this type of linked list is called a circular linked list. And that's it. I hope that you liked my session and keep creating, keep building, and I hope I'll see you in the next session.